So these are the notes for 6.3, 6.4 word problems. The objective is to use proportions and ratios to solve word problems. So let's go ahead and try example 1. So here it says a town is building a new swimming pool. An Olympic pool is rectangular with length of 50 meters and width of 25. A new pool will be similar in shape, but only 40 meters long. So part A says find the scale factor of the new pool to an Olympic pool. Now before we do that, I always suggest draw a picture. Now they have already a picture here, knowing that this is 25 and 50 and the information they've given to us in our word problem, this is the Olympic pool. So I'm going to go ahead and put that here so we know this is the Olympic pool. And then I'm going to draw another picture to represent the new swimming pool. So Olympic pool. What I'm also going to do is identify our lengths as well as our width. So they said with a length of 50 meters. So I'm going to go ahead and put that here. That's good information to know. And then they say the width, and I'm going to underline this. I'm going to underline this so we have that information and we know information is important. And the width is 25 meters. Okay, so now I'm going to build a new rectangular swimming pool here. So I'm going to draw that. This is going to represent our new pool. There we go. And I'm going to label that so we know. There we go. Now they do say that the new pool will have a similar shape, so rectangular, but it's only 40 meters long, okay? So that means long is our length. So I'm going to go ahead and put that here, so 40 meters, and in parentheses say length. There we go. So for part A, it asks us to find the scale factor of the new pool to an Olympic pool. Now, since the new pool came first in this sentence, that has to be on top, while Olympic pool, that's going to be in the denominator. So I'm going to put new pool. I'll do a different color for this. Actually, I'll keep the blue just to represent that. So we have the new pool, and we'll just have to use one of its dimensions for that. And that will be all over the Olympic pool. Now, the only dimension they give to us for the new pool is the length. So we have to use that. So for the new pool, our length is 40. So I'm going to go ahead and put that. So we have 40 over. Now we have to use the corresponding side. So since 40 was the length for the Olympic pool, the length of it's 50. So I'm going to put 50 here. So we're using what we call corresponding sides. Okay. So now make sure anytime that you have a fraction, always simplify it. So I can simplify 40 over 50. So meaning that I want to find a number that can go into both. Well, a number that goes into both 40 and 50 is 10. So if we do 40 divided by 10, that gives us 4. And for 50, we do 50 divided by 10, that gives us 5. So that means that our scale factor is 4 over 5. Now for part B, it says, what is the new width? So when they're asking this, they're saying, what is the width of the new pool? So that's what we'll have to find. And I'm going to label that X. That's our width here. So what we're going to do is create a proportion so we can solve for our X, or the width of the new pool. So how we're going to set this up is we're going to have the length of our new pool. And I'm going to put NM for new pool just to kind of abbreviate it. And that's going to be over the length of the Olympic pool. Now, why is this so? Well, it's kind of how we answered part A is because they are corresponding sides. So length of Olympic pool. And this is actually supposed to be P, not M. So I'm going to erase that. There we go. Equals. So now we have to deal with the width. So the width of the new pool, which that is what we're trying to find. That is the unknown. So NP represents new pool just to make it nice and easy. And then we're going to have the width of the Olympic pool, which we already know. Okay. So now, using this information, well, we know the length of the new pool, okay, over the length of the old pool. We actually already found that with our scale factor. Now, you can once again do 40 over 50, but to make this a little bit easier, I am going to use 4/5 since that's already simplified. So I'm going to have a 4 here, and then on the bottom 5, because that is our scale factor. And I just want to make this a little bit easier so we don't have to multiply very high numbers. Now the width of the pool, that's what we are, the new pool, we do not know. So I'm going to put an X there. And then the width of our Olympic pool, notice it's 25. So I'm going to put that there. So just as you've learned before, now we cross multiply. So we do 5 times X. That will give us 5X. And then we are going to do 4 times 25. That's going to give us 100. Now to solve for X, we divide both sides by 5. And then we get, when we do that, and you can plug this into your calculator if you need to, we get 20. And in this case, we need to make sure we have our labels, so it'll be 20 meters. And that's our answer for example 1B. Okay, so now we're going to do example 2. So example 2 says, use the diagram of the hockey field in which the scale is 1 inch to 50 yards. So part A says, what is the length of the diagram if the actual length of the field is 250? Okay, so here, what we're going to do, the length of the diagram, we don't really know what that is. But we know that the actual length of the field is 250 yards. Now, what we're going to do here is we're going to use our scale factor to kind of help us out. So we are going to have 1 over 50, and that's going to equal the length of the diagram, which that's what we're trying to find. I'll put D for diagram, and then length of the field. So I'll put F for that. So length, F. So doing this, we still have the 1 over 50 because we are just using that as our scale factor here. So that's already given, so that's nice. And I just changed that ratio into a fraction. And you learned this in section 6.1. Now the length of the diagram, that's what we're going to use X for because we don't know. But they do say if the actual length of the field is 250 yards. I'm going to go ahead and put 250 here. And anybody could be saying, like, how did you know to put length of the diagram on top and then length of the field on the bottom? Well, it's using our corresponding side. So the diagram is smaller, so that should go with the smaller number, 1 inch. While the length of the field, remember 50 deals with the yards, 250 yards, well, those are our corresponding sides. So we're going to put it in the bottom. So now what we're going to do is basically just cross multiply. So we're going to do 50 times X, that gives us 50X. And that gives us 1 times 250, which is 250. So when we divide both sides by 50 here, we get as our answer, so 250 divided by 50, X equals 5, and in this case, it's going to be inches, because that's our diagram. So the diagram is represented in inches. The real field, the actual field, is going to be represented in yards, okay? Okay, so part B is going to be similar. So the diagram has now a width of 2.5 inches. What's the actual width of the field? So this is just a reverse. So in this case, we know one of the dimensions of the diagram, but we're trying to find the dimension of the field, the actual field. Now, once again, they have given us already the scale factor. I'm going to put that here so we know this is our scale factor. The nice thing is we didn't even have to find this, unlike the other problem, which we did have to. So we will always use our scale factor. So we will have 1 over 50. So the 1 represents the inch, the 50 represents the yard. Now, since the 1 inch, that represents our diagram, anything that deals with the diagram has to be in the numerator of our fractions. In this case, they gave us the width of the diagram. So I am going to write that as width D, just to represent, hey, that's the diagram. On the bottom, we're trying to find the actual width of the field. So I'm going to put width F, because that's what we're trying to find. Okay, so rewriting this, I have 1 over 50 equals, they said the width of the diagram is 2.5 inches. And then since we don't know the width of the field, I'm just going to put X for that. So now, once again, I cross multiply. Anytime you have an equal symbol, just cross multiply. Now this one's a little bit easier because we can do X times 1, so that gives us X. And then we can do 50 times 2.5, which is going to give us 125. Now make sure, don't forget your units, because we're doing the actual field that's in yards. So I'm going to go ahead and put YDS for that. And that's our answer. Now, make sure while you're going through these notes, if you need to pause it so you can write something down or go back to listen to something, make sure you go ahead and do that. Okay, so now our next one, example 3, this really comes from our section 6.4. So the last two were really coming from 6.3, example 3 and example 4, the ones we're going to do next, they're going to come from 6.4. So for example 4, we're going to use indirect measurements. Or sorry, this is example 3. So it says a building casts a shadow that is 78 feet long. Well, we're probably going to have to use that information there. At the same time, a nearby signpost that is 5 feet tall and casts a shadow at 39 inches long. How tall is the building? So here they give us some numbers, which we're probably going to have to use all of them. Now the nice part is they have already put these numbers onto our picture here. So we can really use our picture to figure this out. So here they've already said X feet, that's the building. We're trying to find the height of it. The shadow of the building is 78 feet. And then for the sign it's 5 feet, and then the shadow's 39. Now if you notice the picture, we are in feet, 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 but then the shadow of the sign is in inches. When you're doing this, you need to make sure that you convert your units to make sure that they're all the same. Now, because really 3 out of the 4 are feet, I'm going to convert my 39 inches into feet. So this will give me the correct answer. So I'm going to put convert because we need to convert this into feet. So that's actually our first thing that we need to do. So I'm going to put in number 1 to say, hey, this is what we need to do first. We need to convert 39 inches into feet. So all of the numbers are in the same unit. Okay, so we know there's 39 inches. Now I'm going to multiply this. Now, when we're doing this, we want to make sure that our inches, they cancel each other out, so we're left with feet. So I'm going to have inches down here, and then I'm going to have feet in the numerator. The reason we're doing this is so we can cancel out the inches, and all we're left with is the feet. Now let's say we have 1 foot. What you have to decide is, well, how many inches are in a foot? In this case, well, in any case, there's 12 inches in 1 foot. So now all we have to do is we're going to cancel out the inches and multiply across. Now this kind of looks weird. All you have to do is put 1 underneath 39 inches to kind of help yourself out, because that's basically the same thing. Okay, so inches, they cancel. We do 39 over 12. I would suggest go ahead and divide that and get a decimal. I'm all good with that, especially since we want to have answers that make sense in the real world. So maybe having a fraction is not always the best. Decimals can work as well. So when you divide 39 and 12, we get 3.25 feet. Please do not forget our units. So now that we've done that, now we can do our proportion to solve for the height of our building. Okay, I'm going to go ahead and scroll down so I have more room. I'm going to put in number 2 because this is where we're going to build our proportion. So starting off, I'm going to go ahead and talk about the height of the building. So I'm going to put that on top. It really doesn't matter where you put this as long as you're using the correct corresponding sides. So height of the buildings. So since we have the height of the building, we need to figure out what is the corresponding side, because these do create triangles. So what would be the corresponding side is another height. In this case, it'll be our height of the post. They both go up and down. Okay, so now we use the other information, which is the shadows. So we know that the shadow of the building, now I'm putting shadow of the building in the numerator because we're dealing with all the building in the numerator, and the post is basically in the denominator. And then the corresponding side in this case, because we're dealing with shadows, is going to be the shadow of the post, which we just converted it from inches to feet. Okay, so now we can place our numbers. So the height of the building, that is what we're trying to find. So that's going to be our x. The height of the post, they said, was 5 feet. Now when you're doing the proportion, you don't have to use your units. You can just put the numbers. Now the shadow of the building is going to be 78 feet. And then the shadow of the post, which we just found, is 3.25 feet. From here, we do cross multiply, so we do 3.25 times x. So we get 3.25x. And then we do 78 times 5. And that should give us a really big number, 390. From there, we want to divide both sides by 3.25 so we can get x all by itself. And when we do that, we get x equals 120 feet. And please don't forget the units. So that is basically the length or the height of the building, 120 feet. Okay, we're going to do one more example, and then you guys can work on your homework. So example 4, it says a cellular telephone tower casts a shadow that is 72 feet long, while a tree nearby that is 27 feet tall casts a shadow that is 6 feet long. How tall is the tower? Now notice on this one that we do not have pictures, so we do need to draw the pictures ourselves. Now just to let you know, when you have these things, you're really going to create a triangle. That's kind of the easiest way to get your answers here. So the telephone tower, it says it has a height or that casts a shadow that is 72 feet long. Now, of course, a cellular telephone tower or anything is going to be going up and down, right? How tall is the tower? Now, we're going to say horizontally, that is our shadow. And so here we can connect these two lines with the line that goes down here to make a nice triangle. So this is, I'm going to label our tower. And I'm going to go ahead and label the information we need. So here we do not know the height, so those can be your X. The shadow is 72. So now we do the same thing for the tree. Now once again, a tree standing goes up and down. And then they say the shadow, so that's going to go across here. To connect these two lines, we're just going to do this little dot, and this is our tree. So notice that both of them are triangles. So the height of the tree is 27 feet, and the shadow is 6. So we're getting all this information from our sentences here. So now basically this is just like we did last time, and it's easier because all of our dimensions are in feet, so we don't need to convert anything. So actually what I like to do is have you guys pause this video and go ahead and try this on your own. So you're going to create a proportion so you can figure out how tall the tower is. Okay, so hopefully you paused the video, you tried it on your own. Let's see if you got the answer correct. So for our proportion, we are going to do, let's just say the height of the tower, since that's already X. So we'll do height, tower. Remember, we need to do the corresponding side, so whatever is the height of the tree. So height goes over height. Then we're going to do the shadow. Now because our tower, we put that in the numerator, I need to deal with the shadow of the tower. And then in the denominator is going to be the shadow, since that is also the corresponding side, shadow of the tree. Okay, so in this case, we don't know the height of the tower. That's what we're trying to find, so I'm going to put X. The height of our tree, the one that's going up and down. Now, if you're like, I don't remember what this represents, I'm going to put H and H to say, hey, that's our height. And I'll put S to represent shadow, so we kind of know what represents what. So we have X over 27, and that will equal the shadow of our tower, which is 72. And then the shadow of the tree is going to be 6. So now we cross multiply. We get 6x equals, so you do 27 times 72. We get about 1,944. To get x all by itself, we divide both sides by 6. And then we get x equals 324. Don't forget your units, in this case, feet. Okay, so that's the end of these notes. Make sure if you need to go back to anything that you can do that. If you have any questions, you can always email me. Come in before or after school. If I'm not available, you can always go to any other math teacher to get help.